Alright, so you saw Mr. Baker's advertisement on YouTube and you thought, wow, I want to make one just like that. Well, not exactly like that, because that would be plagiarism, and none of my students would ever be guilty of that. But one similar to it. How do I do it? The math advertisement assignment that I assigned today has the following instructions. You must choose one of the three methods described right here: substitution, graphing, or elimination/combination. As you'll recall from your algebra class, these are the three methods to solve systems of linear equations. That is, to find the solution to two equations at the same time. Your advertisement, for whatever method you choose, must include the following. 1. A catchy slogan, like, use Linsolv, fool. 2. A nice looking logo, some kind of picture. 3. Clear definitions of important terms. If you recall, in my advertisement, I defined an unknown, and I defined a linear equations. You may use the textbook or any online resource in order to help you out with that one. I also want some kind of example problem. Walk me through a problem as you tell me what your method is. The example problem I used was 5x minus 3y equals 12 and 14 plus y equals 2x. Feel free to make up your own, or again, use the textbook. There's lots of them in there. Number 4, tell me what steps someone would take to use your method. For Linsolv, I had 8 steps listed here on how to use Linsolv to solve the equation. You will give me the steps for your method. And the last thing I'm looking for is a clear argument stating the reasons why your method is better than the other ones. I chose Linsolv because it's easier and faster than the other ones, but you can't choose Linsolv, so come up with something that tells me why graphing is better than substitution or elimination, or why substitution is better than the other two, or why elimination is the best. This is an advertisement. Sell me on why your method is better. This chart here might help you in your assignment. I know you guys filled out a similar worksheet for algebra class where you talk about when substitution is most useful. I'll give you a hint. Substitution is really useful when you already have y or x in either one of the equations. Elimination is really useful if your coefficients for y are the same, like 5y and 5y, or your coefficients in x are the same, like 2x and negative 2x. And graphing is really nice when you have your functions are already listed in the y equals mx plus b format. So tell me, in those scenarios, for those kinds of equations, what makes your method the best? The rubric for the assignment, I thought I had on this PowerPoint presentation. I'll have to look it up real quick here. By the way, you can find all this by Googling systems of equations math advertisement. And look, it's the first, the first link on there. I have this exact same assignment here. And here, excuse me, here's a picture of the grading rubric. So mostly I'm looking, don't worry too much about following procedures. That's just, right there I'm looking at, did you choose something other than Linsolv? If you chose Linsolv, you weren't paying attention very well, were you? Number 2, neatness and clarity. I'm looking for 10 points out of 50 on having a neatly and clearly created product. If you're doing it by hand, make sure everything's nice and legible. Number 3, this is the lion's share of the points. 20 points out of 50 is the mathematics involved. Did you accurately define all your math terms? Again, use the textbook. Did you properly state the steps necessary to use your method? And are your examples good choices to illustrate the benefits of your chosen method? If you choose graphing, I'd probably use y equals mx plus b forms of the equations. Number 4 is your design. This is your creativity part. All right, 7 points here. I want to see a nicely created, polished product. And the last one, argument. 8 points for telling me a good, cogent, logical argument about why your product is the best. Okay, so Mr. Baker, I've got my idea. Now how on earth do I go about doing this? Well, first thing first, you're going to pick which one you want to use. You want to use substitution, elimination, or graphing. I don't know, maybe just choose what you want to do. Maybe I want to do substitution, Mr. Baker. Okay, substitution we said is the best useful when? when you either have an x or a y. Okay? So then you're going to create your equations. So I might have, let's see, I need an x equals. So we'll make x equal, and you can put any numbers you want, doesn't matter. All right, I'm just making up numbers here. And then y doesn't matter so much. I could have y equals, but I don't need it. All I need for substitution is one of the variables solved for already. So maybe we'll do 2y minus 3x equals 10. Okay, I'm just making things up. And now you'll show me. Now you could take this and later on, you know, cast it, put into, take pictures of this, or you can put this into a slide, or you can put this onto a big poster, make it colorful, right? This is my scratch paper copy. This is just my work that I'm trying to figure out, okay, my rough draft. So I'm going to work through this. I need to explain the steps, right? So what are my steps to solving this with substitution? Your first step is make sure that you have one of your variables solved for, either x or y. Hey, look, all I do. Hey, fancy that. That's how I created my example, right? Next step would be to substitute. Anytime you see an x in the second equation, put in this thing instead, right? So I go through, write my second equation, 2y minus 3. Oh, I see an x. So I stop there, and I put parentheses, 3y minus 12. All right, continue. 3x equals 10. Okay? Now what do? Well, you solve this like you would any algebra equation with one variable. First step, I have to distribute across the parentheses. Right? So negative 3, remember that negative sign. Negative 3 times 3y is negative 9y. Negative 3 times negative 12. Be careful, folks. We have two negative signs. Make a positive. 36. And I still have this 2y in front. All right. Just looking at this thing, I'm seeing that my numbers aren't going to be coming out really pretty. I might want to go back and fudge my equations a little bit, make them look better. All right? But as I go along, 2y minus 9y is negative 7y. Remember how to subtract negative numbers, right? 2 minus 9. It's not 11. It's not negative 11, folks. You have one that's positive, one that's negative. You subtract. 9 minus 2 is negative 7, right? 2 minus 9 is negative 7. All right, plus 36 equals 10. All right, okay. Everything, all the like terms are combined. I can now go on to get y by itself on one side by subtracting 36 from both sides, right? Okay, I get negative 7y equals 10 minus 36. Again, be careful here, folks. Negative 26. All right, this is where I was talking about maybe fudging it a little bit, because negative 26, my next step is to divide by negative 7 from both sides. And negative 7 doesn't go into negative 26. So maybe I'll go back up here. I want to make this like a 28, right? And this is okay, because this is my rough draft part, right? Because 7 does go into 28. So if I make that a 28, well, first I'd have to do, what? I'd have to subtract 36 from both sides, right? Oh, 38. I can't do that. Hold on. What could I do? What could I do? We can make this 8, all right? Make this 8. Make this 8. And make this 8. Hey, look at that. Just solved my problem. Okay, make all those 8s. Now I've got 8 minus 36 is negative 28. Woo! And now I divide by negative 7 both sides. I get y equals 4. That's a nice round whole number, isn't it? Okay. So that's my first step of substitution. My second step now would be to substitute this in every time I see a y in either one of the equations. Now, it's usually best to choose this one because, I mean, it's already solved for x, and that's what I'm trying to find next, right? So I'll just take this y equals 4 and plug it back up here, all right? So I get, now on a test, obviously, you can't just change your numbers around, make it easier. But since you're creating this problem, you can change this around and make whatever you want, okay? So I take this y equals 4 and plug it up here. X equals 3. Oh, I see a y, so I put parentheses, 4 minus 12. Okay. What do I get? Order operations. X equals, I have multiplication, I have subtraction. Which comes first? Multiplication. 3 times 4 is 12. Minus 12. Subtraction. 12 minus 12? 0. All right. So I am now done with solving this system of equations, modified version. And I got x equals 0. If I wanted to write as a coordinate, I'd put 0, comma, y was 4. So I would put this on my poster somehow, right? I would delineate the steps too. In other words, I would describe the steps in more detail. I'd put maybe along the side in a different color. I might put step number 1, right? Choose the easier equation, all right? Something that already has an x equals or y equals. Okay? Now, if this were my final copy, guys, I'm getting points off for legibility. My handwriting on my rough draft is pretty sloppy, so don't turn in something that looks like this. Okay, make it look nice. Step number 2, substitute, right? So you're gonna write this in. I'm not gonna do your work for you guys. I'm gonna go through every single step. You gotta put this in your own words, all right? Substitute that in. Number 3, go through all this, all right? Here I am substituting, here I am distributing, right? Number 4, here I am combining like terms. Here I am getting y on one side, or isolating the variable. That might be a good way of saying it. Here I am, number 6, dividing by the coefficient. Okay, and number 7, here I am plugging back in or substituting it back into the other equation, right? Coming back up here, substituting back in there, and order operations to solve for x. Solve for x by following PEMDAS, right? Order operations. Okay, blah, 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 like 8 steps or something like that. Now, you're going to put more attention into this. I've already done my assignment. I'm just trying to give you some ideas, all right? And then make this look nice. You got your nice steps here, right? Put a little slogan on it. Maybe put a picture of somebody saying this is a cool way of doing it. And then what's the argument about why you should use substitution? In this case, remember, this is you created it yourself, right? This is your system of equations that you have to argue substitution is the best. Why would substitution be the best for this system of equations? I can tell you right away, it looks like the best, because this would be hard to graph. This would be hard to do a combination on because, it's hard to graph because I don't have any y equals. And it's hard to do combination on because none of the coefficients are the same. I got 1, I got a 3, negative 3, I got a 3, I got a 2. That'd be hard to do combination on. But hey, look, I got an x equals. That'd be easy. This is an easy one to do substitution on. Imagine that, right? So that's why substitution is the best. So come up with something about that, all right? Tell me why this is the best. Now, if you want, you can put this into a nice little spreadsheet. You can go Google image like Mr. T like I did, or some kind of a picture of some celebrity or something, that you might see in advertisements. You can voice over a commercial like I did in my video, or you can just make a nice looking poster and include all this information. But make sure, again, that you're addressing all of the points on our rubric. All right, let me pull that up again. We got our rubric here. Make sure you're looking, things are nice and neatly done. Make sure you're not just copying my stuff. Guys, I'm going to take off points if you just copy, hey, I got this equation right here and these are my steps. Don't copy Mr. Baker, just think through it yourself, right? Mathematics, define all your math terms. Okay, I didn't do that on this one, but all these words that I used, I need to define them, right? I need to define equation, I need to define substitution and distribution. I need to define combining like terms. All these things, I should define them on a little corner. Or like I did in my commercial, right? Say them at the very end, put them in small print. That's what they do on advertisements. They put them when no one's paying attention, right? PEMDAS maybe, right? Coefficient, okay? Defining these terms. I want you to tell me what they mean, right? I want you to use them and also tell me what they mean. And then again, some kind of slogan or logo. This wouldn't be done unless I have, like substitution, and you can use your artwork. Maybe some kind of lightning bolts come down. Oh, you can't see this. I'm screencasting. Here we go. Maybe some kind of substitution, right? And it's not just for your grandma. I don't know. That's a pretty stupid slogan, but it's kind of funny, right? Whatever you want. Substitution. It's not just for your grandma. And you might have a picture of a grandma saying, you know this, your grandma. Okay, here's your grandma. And she's looking at you like this, right? It's not just for you. I don't know what your grandma looks like. But probably something like this, I'd imagine. Most grandmas look something like this. And they got those big pointy shoes, right? And they got like a floral dress. All right.